We are going to be discussing the efficient workforce allocation in manufacturing, and we are using AnyLogic simulation to do that. So a little bit about Cargill. Everything begins with our purpose to nourish the world in a safe, responsible, and sustainable way. Every day, Cargill employees around the world come to work. We drive to improve the lives through food and nutrition. We look for ways to improve and innovate, and we are determined to nourish our world in a safe, responsible, and sustainable way. We connect our customers and suppliers to the world by developing personal relationships and setting standards high on the way we work. We support customers with a world of expertise delivered locally, quickly, and reliably. We also, we succeed, the way we succeed is just as important as success itself. We approach business with a sense of respect and responsibility. At Cargill, we have more than 160,000 employees across 70 countries, working as a global network in 125 markets, bringing together the people, ideas, and resources that can impact lives across the world. We have a combination of 159 years of experience with new technologies and insights, and we are in a lot of different areas, including food, agriculture, finance, and industrial. All right, where can you find Cargill? We are found in a variety of areas, from ingredients and products you may see in your everyday life. Some of our examples are listed, and some of our highly recognized brands include Nature Fresh, Purina, Diamond Crystal, and Truvia. Every day, our employees deliver on our purpose and drive innovative solutions. 61% of our employees work in our plants, and that is where we will begin our efficient workforce discussion. All right, so high volume manufacturing facilities are subject to a lot of uncertainty due to unpredictable equipment failures and the variable workforce availability. One of these challenges, we have developed a day of operation simulation tool for optimal workforce allocation in these uncertain environments. This tool is particularly beneficial for workforce intensive facilities where the production process involves multiple jobs, each requiring at least one worker to perform the necessary tasks. The tool utilizes a worker proficiency database that was created, expressed in terms of full-time equivalents, or FTEs as we say, to rate the workers at 100, 75, 50, or 25%. A 100% FTE rating signifies full proficiency. The tool considers real-time workforce availability on the day of operations, including our overtime workers. Its objective is to optimally assign workers to jobs, ensuring that every job is staffed, every worker is assigned a job they are proficient in, and overall throughput is maximized. The output of this tool is integrated in our facility's digital twin, developed using AnyLogic, and the digital twin can utilize the day of operations demand, optimal workforce allocation, and random downtime events for equipment to identify throughput limiting tasks and calculate the overall throughput of the day. The integration of the workforce allocation tool and this digital twin enables our facilities to make informed decisions both short-term and long-term. All right, we will jump into our business challenge. During our production data review, we noted that there are a few labor-intensive facilities. The daily expected production was not being met. Upon further review, it noticed that the facility would almost always utilize a ramp-up period when labor arrived or left. So as you can see in the chart, in the beginning of the day, they started at around 60% of their production rate, and that was ramped up to 100% in the first 45 minutes to an hour. You'll also see that there was another drop later in the day. This is when our overtime workers left for the day. And then depending on where they were working, managers would have to move people to get back to our daily production. In addition, production is split into lots, and the production rate was always set at a flat daily goal and not adjusted for the different products we were producing in the different lots. So we'll go through some of the challenges that led us to develop this tool. Due to operator absences, managers were scrambling to resolve those startup bottlenecks and adjust job allocation. New or substitute managers struggled with the labor allocation planning. Management sought to understand the true production rate capability by lot and product in order to make value decisions. We wanted to allow for decisions to create a high value product that might require more labor versus a low value product that required less labor. And we also wanted a tool that had minimal time investment for daily use. We wanted our operations to run this tool fast and efficiently.
Okay, so let's talk about the inputs that were utilized to develop this day of operation tool. This tool is designed for facilities that have over 15 departments, each with more than 40 operators, and such an extensive setup requires a robust system to ensure smooth operations across all departments. This tool also accounts for the fact that operators are trained on more than one job, and as this cross-training enhances flexibility and allows for better allocation of operators based on operational needs. Certain jobs within the facility are designated as critical. The tool prioritizes these critical jobs to ensure they're always staffed appropriately, maintaining optimal performance and meeting key objectives. The tool addresses workforce reliability by tracking real-time instances of absences or no-shows. This feature helps in planning and adjusting schedules to minimize the impact on daily operations. And finally, operators are assigned a full-time equivalent or FTE value, which can be 25%, 50%, 75%, or 100%. The tool uses these FTE values to accurately represent the contribution of each operator, aiding in workforce planning and resource allocation. Now I'll talk about the methodology that we used to develop this tool. So the foundation of our day of operation tool is mathematical optimization. And this technique leverages mathematical principles to identify the best possible solutions or optimal decisions for complex and real-life problems similar to the ones that we are trying to solve. We applied these mathematical optimization in our facility's digital twin to optimize the labor allocation. And in order to do that, we utilized two methods. Method one utilized the AnyLogic-based digital twin, an external optimizer, and AnyLogic's pipeline library. Method two, it employed the same AnyLogic-based digital twin and external optimizer, but we integrated the optimizer using AnyLogic's built-in Java capabilities. And I'll talk about these methods in the next few slides. So here we present a general mathematical optimization approach that may be utilized for optimal labor allocation in any labor-intensive facility. However, it is advised that individuals may have to adjust this formulation to suit their requirements. The objective function here is to maximize the throughput. And this objective is subjected to three primary constraints. The first around the workforce, second around jobs, and the remaining constraints around throughput. So let me talk about the first method that we used. So for any organization, data is available in several forms, be it on servers or locally on an individual's computer. In Cargill, we have explored several input formats that a digital twin can utilize and found that using a JSON format is one of the easiest to work with. As most of us may know that any simulation model developed in AnyLogic is a Java application that can be customized natively using Java programming language. However, it is also possible to introduce Python as an auxiliary programming language within these simulation models, enabling the opportunity to use Python-based libraries and algorithms. And Pipeline is one such library which is developed by AnyLogic that can be used for cases such as utilizing code that was originally written in Python without having to port to Java. So we tested the use of Pipeline on desktop AnyLogic as well as on AnyLogic Cloud. And Pipeline here is used to call a Gurobi Python-based optimization script that utilizes Cargill's Gurobi server to perform the optimization task. And the result in this particular case is an optimized labor allocation plan, which is then fed back into the facility's digital twin for use. And this process is repeated throughout the day of operation or whenever there is any change in the facility's labor numbers or production lot. Now, moving over to the second method, the outcome of this second method is exactly the same as the previous method that utilized pipeline. However, here we utilized AnyLogic's built-in Java along with other necessary Java classes. The main reason for us to explore this built-in Java was to communicate with the external optimizer, and also due to the limited availability of online resources around troubleshooting. So it is worth mentioning here that we were able to successfully connect our AnyLogic cloud to several of Cargill's servers and pull in the facility's real-time data, such as product demand, labor availability, and even the equipment downtime. So essentially, every time we run the facility's digital twin, we would pull in the real-time data for use. Also, as we explored this Java connection, we also successfully tested ways to programmatically create and read Excel files into AnyLogic database. Especially when working with AnyLogic Cloud, now a Cargill modeler can connect with several servers to pull the data, make modifications to that data, and feed it back into the facility's digital twin. And as the digital twin is executed, it utilizes that data from the built-in AnyLogic database. Now, moving on to the demo of our work. So Cargill, for a long time, has now been utilizing AnyLogic's cloud capability to share the simulation models with our users in several businesses. Here is the demo of a part of our day of operation tool. And as you see on your screen is the interface where, depending on the model requirements, several parameters can be added. We here have shown the option to enter the date the user wants to run the model. They can select the facility that they want to evaluate, select the shift that they want to optimize, and also select if they want overtime workers or not. So once all this selection around date, around facility, around shift, etc. is complete, the users can save their input and play the simulation model. Now, upon playing the simulation model, this model connects with Cargill's internal databases for that selected facility and pulls in the data around the demand for the shift, the real-time worker availability, their proficiency levels, the number of jobs there are in the plant, etc. And using all this information, we create an input JSON, which the model then reads and provides us with a list of departments available in each shift. And now the user can select the departments they want to optimize and generate an optimal allocation plan. So once selected, the model connects with our Cargill's Gurobi server that performs the optimization task and provides this optimal allocation plan that you see. And this optimization task is completed in less than 300th of a second. And we are provided with the optimal allocation plan. So for instance, in this particular case, we get the allocation plan for all positions through A through J. And based on the operator's proficiency level, we see the optimal allocation of operators on all the positions. So depending on where we are executing our digital twin, AnyLogic desktop or AnyLogic cloud, this optimal labor allocation plan gets fed into the facility's digital twin. However, due to the sensitive nature of the information that is contained in the facility's digital twin, today we are not going to demo it. However, we can certainly say that the analysis of the output data from these digital twins for the various facilities has helped our businesses make significant financial gains.
All right, and we will go more into some of those results. All right, so overall, we saw on average for our facilities a total increased production of 1.56%. A lot of that time came from those 2 ramp-up periods we saw. So in the beginning of the shift, the time of the ramp-up period and the impact of the ramp-up period were reduced. It was not completely eliminated in this case because we still cannot run the simulation until the operators have arrived for the day. They still have to clock in to know who's going to be here. So there was still some ramp-up period. However, we did see that the ramp-up period after the overtime people left was eliminated completely, as the managers were able to run the simulation throughout the day to determine what should the allocation plan be in the next hour or 2. We also demonstrated the production of higher value products and the incremental margins justified for the use of that extra labor. We allowed for labor-based day of operation adjustments. We increased the management effectiveness and a lot of the operator safety by decreasing the bottlenecks and the strain our operators were facing when either put at too high of a speed or too low of a speed.
All right, I think this brings us to the end of our presentation, and we are ready to take questions.
All right. I see one of the first questions here. In method 1, how did you get pipeline to work in the cloud?
Oh, okay. So we have our own Cargill private server for AnyLogic Cloud. And on that cloud, we got Python installed. So that way we were able to successfully connect pipeline with our cloud.
Yes, and I would say that there was a lot of back and forth with AnyLogic.
Yes.
So it wasn't necessarily easy, but it was able to be done. How you test it with large scale models. So this was put out to multiple of our large facilities. And so we did validate it. There was a couple of different things we validated. Obviously, we did historical data and throughput, as well as we talked with the managers on how our allocation plan was coming out. But we also put a lot of that validation on our management staff themselves, as they were able to manipulate some of those inputs and see the allocation plan. Did it make sense? Was someone being allocated to the wrong job or too many people in a job? Those kinds of things were also done. From a performance standpoint, we didn't see any slowdowns from the Gurobi from either method 1 or method 2.
No, we did not see any slowdown in the performance. And of course, running it on AnyLogic Cloud actually helped us to speed up the performance.
Yes, and the optimizer was called, I would say, each simulation run anywhere from 12 to 24 times, I would say.
Yeah.
And again, it was optimizing. I think we have how many? 15 departments?
15 plus, yeah.
In each facility.
And then several production lots in each shift. So you can imagine for each production lot and for each department, we were calling our optimizer.
Yes. All right. Whether your assignment or optimization process decentralized or used a master server?
We are using a master server. We have a Cargill's Gurobi server for us that we can connect to, and that server does the job for all the optimization tasks that we have to run.